Right, we'll have to finish off the valve house very quickly before we can start doing the assembly. So for my part, I need to change project. Since I did this with Group B on Friday, I need to switch back to the A project on my computer. So I'm going to open up the housing part. So housing.ipt. Because we managed to create the sketch last time, but we didn't get to do the revolve to cut out the internal stuff in the housing. So I just want to double check that I managed to finish off my sketch. So I'm going to double click over on sketch 4 in the browser tree there. So double click on the icon and it's going to open up the sketch. I'm just going to press the F7 button in order to get to see the sketch itself. It's not that important that we get it completely correct here. The most important part is that we actually manage to hollow it out for the assembly part. Because we're not going to manage to finish off the housing anyway before we start on the assembly. So that just being able to do the revolve here to make it hollow is all that we need. So once we've gotten back in here and see that we can actually revolve the sketch, we're going to click Finish. And then we're going to use the revolve function up there. And we have to choose which outline we're going to revolve. So we need to find the one from our sketch. So that was mine. And we also have to click on the axis. So we need to click on the axis button up there. And then we need to find the center line going through our sketch. So we click on that one also. And if I tilt it around here so that we can see it, it's not cutting now because it's adding new material. So it's basically just placing material inside the material. So that's no point. So we need to switch the option over here from joining to cutting. And then it's actually cutting a hole into our valve house and creating a hollow section. Once that is done, we're going to click OK. And we also want to place the clearance holes for the flange. So we're going to create a sketch on the flat of the flange here. So create a new 2D sketch. And we're going to place it on the flat of the flange. We're only going to place one of the 4 clearance holes in this one because we don't really need more in order to do the assembly properly. Because we don't have that much time to do the assembly, so we need to get a move on. So we'll be placing a single point. So we'll click on the point function. We're going to place the point on the flange here. Then we're going to use either a vertical or horizontal constraint in order to constrain it to the center point. So my vertical one is going to constrain it vertically above the center point. So I click on the point I placed and I click on the center point, and now it's locked into place above there. Now I need to set the distance from the center and to my new point. From the center and to the new point. And that distance was supposed to be 52.1. So 52.1. And then we click enter. The reason why we have to have at least one clearance hole here is that we're going to use that clearance hole in order to match up our other flange that we're putting on top of there. So we need to have it. Once you've gotten the point in place there, we can click on Finish Sketch. And we're going to use the hole function. And it's going to automatically choose the point that we created in the sketch. And we need to switch to, let's see, we need to switch to the clearance hole option down here. So then we get some more options to choose from. And we need to set it to be ISO as the standard. And we want regular hexagonal head cap screw. And the size of the clearance hole is going to be M12. And we're going to have a close fit. Now this is a typical one where we actually can't use termination through all. So we can't use the one with through all because it's going to be all right with this hole. But if we were to create all four of them, then the two holes on the sides here would be directly above the wings of the flange, and they would be cutting straight through the entire flange. So on this one we need to use the 2 option and switch around to use this selection button to click on the underside of the flange. And that's going to make the hole only through the flange and not through all. Once that is done, we can click OK. So then we have one of the clearance holes. Preferably we would have created the entire housing there, but in order to get as much time as possible for doing the assembly, we're just going to stop there because we have what we need to actually assemble the parts at least. So we're going to just save our part, and then we're going to start a new assembly on this one. Yeah. Oh, that's not a problem. Yeah, that's okay. So we click on the new one. Make sure we're in the metric folder. And we find the standard in millimeters .iam. So that's the assembly type file. We're going to click on Create. Har vi ikke tatt sideventilene og sånt heller. Altså, eller sideflensene. Hål igjennom og sånt. Then we need to place our first part, which we are also going to lock to the origin of the or the origo point in our coordinate system. So we're going to click place, and we're going to place the housing itself, the one that we just finished off and saved. So we click on open. Need to zoom out a little bit. So before we click on the left mouse button, we want to click on the right one to get up an extra menu here. So once you click on the right mouse button, you get this navigation menu up. And the one we want is to use place grounded at origin, which means that it's going to place it in the center of our coordinate system, and it's going to lock it in place there so that it can't move. It's going to make it a little bit easier for us to navigate when we're working with the other parts. As soon as you click place grounded at origin, it's just going to be fixed there. So I'm going to click place grounded at origin. And OK. So we've gotten this one in place. I'm just going to flip it a little bit around to see it from a better location. I'm also going to zoom out a little bit just to get some room to place more components around it. So the next thing we're going to do is that we're going to get to place all of our components before we start constraining them together. So we're going into the place option again. And we're going to need to place the shaft, the valve flange, and the wheel also. So all three of those parts, we need to place those in here. So we'll just do one after the other. And it's not a problem if they're oriented in some other direction or anything like that. It just means that you chose another plane to start your first sketch on than what I did originally. So it just means that it's going to be tilted in another direction. So that's not a problem. We're going to correct everything when we start putting it together. There's still a couple of components that we're missing because we're going to have to need bolts to go through the clearance holes in order to screw the top of the valve tightly onto the housing. So we're going to need 4 M12 bolts and 4 M12 nuts that we're going to put in here. We're also going to need an M14 nut that's going to be used because this wheel is going to be screwed onto the thin threaded section of the shaft, and then we need a nut up top to lock it in place. So these are parts that we need to put in, but we haven't created these. So we're going to need to pull them from the library because they are standardized parts, so we can just use what's available. So we go into the drop-down menu over on Place here, and we use Place from Content Center, which is the library part of Inventor. And here we see we get quite a lot of choices to look at. We'll go over for fasteners in order to find our bolts. And I just need to find the correct ISO standard to use. We're going to go into the bolt folder. We're also going to use hexagonal head, hex head. And we're going to locate, let's see, the ISO 4014. So we're going to look for 4014 in an ISO part here. So here we have one. It's a German standard, Deutsche something, and European norm, ISO 4014. Once you've marked that one, it says DINENISO 4014. Then we click OK. And we can see we have sort of something really tiny here. There is a possibility here of letting Inventor do the choices for you, because we can actually click on the clearance hole and it's going to choose the correct size for our bolts. As you can see now, it changed the dimension to M12 because it was an M12 clearance hole we had there, but it doesn't know the length that we need for it. So if I just click randomly here, I've locked it to the clearance hole, so I just need to place it again. See the ISO there. If I just click randomly in here before I hover it above a hole or anything like that, then I get to set all of the parameters myself. So then I get the thread description over here, so I can choose M12, and I can also choose the length of the bolt. In this case, we're going to have the shortest one, 50 millimeters. But you can, it's also possible in this particular type of bolt can also be gotten up to 120 millimeters in length. So M12 as the thread description and nominal length 50 millimeters. Now for your CAD project also, or the mechanical design project that you're creating, this is also perfect whenever you need to use bolts in it or anything like that. Don't bother with designing the bolts yourselves, just pick them from the content center. You're going to save a lot of trouble by doing that. So once you've gotten M12 and 50 millimeters in length in there, you click OK. And now it's previewing the correct size bolt for us here. And we're just going to place one of them there. We're just going to place one, we're not going to place all four. Basically because we can place one bolt and one nut to hook them up together, and we can use circular pattern to get all four afterwards. Just to show you that it's possible to use patterns in an assembly also. So then we need to place the M12 nut. So we go back into the, not place component, but place from content center over here. And I'll go back to the fasteners out there in the browser tree, fasteners, because then I have a folder named nuts, which I can go into. I'm going to double click that one. And we want regular hexagonal nuts for this one. And we're going to find the ISO 8673. So ISO 8673 is the one we're going to locate. So we probably have to scroll a little bit. So this one also has the DIN EN ISO in front of it. 8673. And as you can see, there is quite literally a jungle of different standards to choose from. So sometimes it can be a bit daunting trying to choose the correct one, but usually it's better to just choose one and see if it's going to work instead of trying to determining everything beforehand. Once you've gotten the correct one, 8673, you click OK. And for this one, we're going to let Inventor automatically choose M12 for us. We're just going to hover it above the threaded part of our M12 bolt. And now it says that size is not available in that one. Let's see. It might be that I've chosen the incorrect 8673. Ah, that was the incorrect one. That was the M14 one, which was 8673. Let's see. I'm just going to place it anew here. So 8673, we're not going to hover it across the bolt, but we're going to hover it across the M14 part of our thread on the shaft. That's going to choose M14, and you can even see that it says M14 times 1.5. So it's already figured out that these are fine threads, they're not coarse threads. So Inventor has done everything for us here. Then we can place the nut here. Didn't want to connect it properly. Let's see. Yeah, we just need to place it there. Then we're going to back to the content center. We're going to have to use another ISO in order to get the M12 one, and that is ISO 4032. So 4032, and that one is over there. DIN EN ISO 4032. Once we click OK, we can hover it above the bolt. And we need to just connect it to the bolt to begin with. M14 times 1.5. Jeg brukte sånn autoplace. Bare hold over gjengen han skaper, så kan du sette fast der. Ja, men du må feste den til kanten på, ja. 40-32. So then we can start constraining our parts together. We'll start off by putting the top in place so that we can place our bolt and create a pattern. Even though we have only got one hole on our valve housing, we will still be able to create a pattern of bolts going through it. So there's just going to be a collision of materials there. But it doesn't really matter for our particular assembly here. So for the assembly itself, it's not a problem. So the first thing we're going to do is to place the top here over onto the housing. So we'll go to the Constrain window. And last time we did an assembly, we only used the mate one. We didn't use any of the others. But this one, we're going to use quite a lot of the one that is called Insert. So we're going to go over to Insert on this one. And what we're going to do now is we're going to, at least for my part, I need to flip my view a bit because I want to see the underside of... actually, I don't need to see the underside. I can do this from the side here. I'm going to mark the lower edge of the top, the valve flange. So I'm going to click on that one. And then I'm going to mark the upper edge of the flange on the housing. And I'm going to click on that one. So then it has perfectly centered it. It has placed the two surfaces against each other, and it has perfectly centered it. So we've done, so instead of having to first place the surfaces against each other and then centering it, we've managed to do two things with just one click on this one. So it's a bit more time efficient when we're working with it. So then we're going to click Apply. Now we need to make sure that it's going to stay in position properly. So we're going to go back to the mate type, this one. And we're going to click on one of the clearance holes so that we get the axis of the hole marked. And now we need to tilt it a little bit because we need to find the clearance hole on the lower part of the flange. And we're going to mark that one also, because then Inventor is going to align the axes with each other. So it's going to make the axes be on the same line. So once I click on that one also, we can see we get a blue line going through all the way here. One way I can show this a little bit better is if I deselect the first one I did here, just to signify what's actually happening here. If I select this hole instead, over on the side here, it's going to rotate the flange 90 degrees until they are on top of each other. So it means that it has put this hole on top of the other hole. And this was the reason why we needed at least one hole in the lower flange, because we needed to align it this way. So once we've done that, we're going to click Apply. So now our valve top is completely locked in place. It's locked to the center of the valve housing. It's locked to the top of the flange, and it can't rotate. So we've gotten it locked down completely. So then we're going to do a break, and after the break we're going to place the bolt and the nut, and then do a circular pattern with them. Right, then we'll start off with getting the one bolt and nut in place. And I think think I've, by using that automatic placement on the nut, I think I've actually constrained it to be attached to the bolt. So I'm just going to remove those mates on that one, just to make sure that I can move it on its own, because we need to be able to do that. It can't be connected to the edge of the bolt. We're going to screw it on and make sure that it's tight there. So again, we'll go into constrain, and again we'll use the insert function, which is perfect to use when you're putting nuts and bolts in place. So we'll click on the insert function. Just to let you see what I'm doing, I'm going to zoom in a bit on the bolt here first. So I'm going to choose the circle that's all the way at the end of the cylindrical part of the bolt first. So I'm going to click on that one. Then I'm going to zoom out a bit, and I'm going over to the hole, and I'm selecting the circle on the edge of the hole. As soon as I click on it, it places the bolt inside, and it places it all the way into the hole. Sometimes you end up with it pointing in the wrong direction. Then you have the possibility of switching directions up here. Basically the same as we did when we use the mate function, if the surfaces are going to be facing each other or if they're going to be facing the same direction. So it's the same stuff we can do here. So we can click on this one, and it's going to turn it around and put the head of the bolt inside the material and the cylinder upwards. So we don't want it to be like that. In our case, it was correct the first time around. But if it ends up being the wrong way when you put it in, you can just switch the direction. So that was the point of showing that. Then we click apply. And I'm just going to show you that it's been placed in the hole. I can't pull it upwards or downwards, but I can rotate it, actually. So that's a possibility still, to rotate it. And for a bolt, we're not going to bother with locking it in place so that it can't rotate. So we're just going to leave it possible for it to rotate. Then we're going to go back into the constrain, and now we're going to put the nut in place. So the constrain there, again, insert. We're going to zoom in on the nut. And we can see here, around the edge of the nut here, there is a flat surface. And that's the flat surface that's going to be pushed into the flange. So what we want to do is to select one of the edges of that flat surface, either the inner edge there or the outer edge there. It doesn't really matter which one we choose, as long as it's one of those two. So we'll click on one. We'll zoom in a bit here, and I'm going to flip it around so that we can see the underside of the flange. So I'm flipping it around here. And now we're going to click on the edge of the flange. So we're not going to click on the bolt, we're going to click on the edge of the flange here. Once we click on it, it sets the nut in place. So now it's placed the nut all the way into the flange so that it looks like we've actually tightened it. So remember to click apply once you've put it in place. So now I'm going to just tilt it a little bit so that we can see here. So the next thing that we're going to do is to create a circular pattern out of both the bolt and the nut. So we go up to the top here where we have one that says pattern. In the assemblies, we don't have separate ones. We don't have one that says circular pattern and one that says rectangular pattern. We just have one that says pattern, and that's all it does. So we click on it, and now we get to choose between having rectangular pattern and a circular pattern. So we go to the tab that says circular, Click on that one. And then we see the mouse pointer up here says that we need to choose a component. So we're going to click on both the bolt and the nut, so that we get both of those marked in blue. Then we need to go to the second red arrow that we, or red mouse pointer that we have here. We need to click on that one because we need to set the axis that the circular pattern is going around. And what we're going to do then is just to select the edge of the flange, because that's going to give us an axis. And in this case, the default option was 4. So we placed 4 of them up there. So that was perfect in our case. Once we click OK now, we can see that we have 4 bolts and there are also 4 nuts in place. So we have them all placed in their correct holes. I'll just go back into the component pattern so that you get a chance to see all of the settings. So once you've gotten the pattern in place there, we can zoom out a bit so we can see everything here. the next step will be to constrain the wheel to our shaft, and then the nut to our wheel, so that it looks like we've screwed it on tightly. So we'll go into the constrain, and again we're going to use the insert function. It is usually, so long as there is something cylindrical that you're going to attach together, it is the best option to use. So we click on the insert option, and we're going to flip around to the underside of the wheel so that we can click on the edge of the threaded hole. So we'll select the edge of the threaded hole there. And once we've marked the edge of the threaded hole, we can flip it back around. And we need to flip it once more so that we can see the edge of the 14mm threads there. So when we click on that edge, like this, the whole wheel comes into place. So if I flip it back here, we can see that the wheel has been placed all the way into the larger threads, so it's flush with those. So I'll click apply just to set it there. Then I'm going to have to remove the constraints I set on the nut here in order to be able to place it correctly. And I'll do another insert constraint to get the nut placed all the way into the wheel there. So the insert constraint, I'll choose the edge of the threaded hole on the wheel. Then I'll flip around, and I'll zoom in so that I can see the nut properly, and I need to choose one of the two edges on the flat face of the nut. So this one for an example. So once I click apply, the nut is all the way in there. So now the wheel is fixed in place. Okay, so we've gotten to do quite a few of the insertion assemblies here in order to show you how those work. And it's usually the mate where you have a flat surface against a flat surface, or the insert one where you have cylindrical surfaces that you're connecting together. Those are the two most commonly used constraints when you're setting it. We're going to just save our assembly right now because we also need to look at how we are going to animate this stuff, which is also a part of the project and even the last submission, so we need to actually go through it. So we'll just save. I'll just call it assembly. And then we'll create a new one. And now we need to go all the way down, and we want to use the standard in millimeter .ipn. And you can see on top here it says presentation. So this is when we are sort of creating a 3D animation of how you assemble this part. So we click on that one and then create. So standard in millimeter .ipn. And then it immediately wants us to insert an assembly. And I can see that it's slightly different from, not even slightly, but quite a lot different from 2015 and 2016 now. So we'll see if we can make this work. I haven't done it in 2017 before. So the main way that we do stuff in here, make things happen, is that we use the one that's named tweak components up here. And what we can do with this one is that we can select one part and we can have it do something. So we can have it rotate around an axis, or we can have it move along an axis. So for an example, if we want to move one of these bolts off, if I just click on the bolt, we can see here it's giving me the three axes to choose from. So if I choose the vertical one, then I can click and then drag in order to specify how far it's going to move along that axis. So now I've just dragged it randomly up here. And once you've moved it in a certain direction, and then you click the OK button, then it should be possible for us to run this animation. So we just pull the slider here all the way back to 0. And if we press the play button, it shows the bolt moving upwards. Actually looks like we can just run the play button straight off. So we've animated the bolt as moving upwards. So now we'll try to add another tweak. We'll choose the same bolt because we would like it to actually rotate while it's moving upwards. So again, we're going to choose the upwards axis. But now we need to switch to rotate up here. So previously we used the default, which was move. Now we're going to switch it to rotate. Then we get a couple of new axes here. So what we need to do now is actually drag it in a circle to show how much it's going to rotate. So if I keep on dragging it here, it's going to show a full circle as we go along. So I put in a full circle there. Or let's see. It's not doing what it's supposed to do, but well, I'll try once more. I'm supposed to rotate it. I set it for a full circle here, it gets... Let's see what happens now. This is quite a lot different from what it was earlier, but we'll just have to try to figure out this as we go along. So now we've gotten half circle. Let's see, I'll try to do something with the nut also. So moving the nut downwards. I'll move back here. And I'll also put in rotation on the nut. So select the nut and rotate. So let's see what happens. Now we have rotations on both. Okay, so once we've gotten this far, we've whether you've only done the bolt or if you've done both the bolt and the nut, doesn't really matter, but we've gotten it moving upwards and it's rotating at the same time. But in order to get to show everything here, ideally we would do all 4 bolts. We would pull the nuts off and the bolts up, and then we would move them away so that we are left with just the housing and the flange top there, so that we can sort of see what's going on here. We don't have lots of bolts and nuts in the way blocking our view. So what we want to do then is do another tweak, but we now have to make sure that we're over here, that we're at 2.5 seconds, because then we're going to add it after the 2.5 seconds. We're not going to do it simultaneously. So we click on this part, and if I then start moving it off to the side here, click OK, and then I can do the nut also. I can move it off to the side and click OK. So now we can see the total timer here is now at 7.5 seconds instead of 2.5, which means that we've done them in a sequence. So now we have a sequence of things that are happening. So we can push the play button, and we'll see that they'll be moving away from each other, and now we have them moving one by one. It would have been better if we had them moving at once. Would have looked a bit cooler, but at least we've gotten the end result correctly on this one. You can do the same. You don't have to do this with just bolts and nuts. You can move the housing and the flange top also. So if we do that as the next one, we'll just pretend that we've moved away the other 3 bolts. So we can move up the valve housing. And we can move it sideways in a different direction. So if I just keep it zoomed in here, if I run the entire simulation now, I'm pulling the bolt and the nut away, and then I'm moving up the valve housing, valve top, and over to the side. So this allows you to basically show how you've put everything together in the assembly. So it's quite a bit easier now than what it was before. So when you're going to look, if you're looking in the compendium on how to do the animation, it's going to look a lot more difficult than this, because in the old versions you had to do it in the reverse order, so that you would constantly be working in reverse of what you were doing in order to show it. So it was a bit difficult to do everything then. Now it's quite a lot better to show it. So I would recommend that you start moving about, tweaking your components, just trying it out to get a feel for it, and I'll join the assistants in walking around and helping people. Right, so that's it for the lecture today. We didn't get time to do more, but just fiddle a little bit around with the tweaking and moving of stuff here. So just try to get it as nice as you can get in the submission. Considering that it's pretty different now from the compendium and stuff like that, I'm not going to I'm going to take that into account when I'm grading the animations and stuff like that. So if they you don't have that much possibility of learning it from the compendium, so try to get some extra practice on it, and then we'll see in the submissions.